Hi guys, I am teacher Boaz in your lovely room today. I teach mathematics, physics and key stage 3 science for the students taking the Cambridge system, that is the CIS, the Cambridge International Assessment. Now today I'll teach you about variation. I'll give you different types of variation and we'll have quite a number of problems actually to solve so that we can be in better practice. Now, basically speaking, what we normally do, I have an organization, a company called Disneyland Media International. In our Disneyland, I will share with you what we do before taking you through. We do mentorship, we do conferences, and our main target is teenage, the students in middle school, like those people in year 6 going to do the checkpoint. We do the high school, the A levels, that's advanced, subsidiary, and the A level. We also deal with the campus students, the university students. So if you want your children or your child to be mentored, you can get in touch with us. We mentor them on studying techniques. You know, this generation, there's a lot of influence from the internet that really interferes with their studying techniques. And you find your child doesn't do well, at the end of the day, they don't get good grades in mathematics and science. And remember what? This is what will really help them improve or get into the better careers. So you can subscribe to our channel, Disneyland Media International. The YouTube name is Disneyland International. You can also search by my name, Teacher Boaz. You'll get all my video, my tutorials, my mentorship, my conferences, and my mathematics lessons. Keep following us, subscribe, and share with your friends. So today I want to take you about the variation. Now, I have a table here that says the number of bottles and the cost in dollars. Now, you see if it is one bottle, the cost is $4. If it is 2 bottles, the cost is $8. 3 bottles, cost is $12. It increases all the way. When there are 6 bottles, the cost is $24. So I want us to learn something from here, then we derive the term variation, something that varies. You can clearly see that the cost in the number of bottles varies directly as the number of bottles. As the number of bottles increases, the cost also increases. Let me give you this example. If you take 4 here, divide by 1, we get 4. It's the same as when we take 8, divide by 2, we still get the answer 4, which is still the same as 12, divide by 3, we still get 4. The same as 16, divide by 4, the same as 20, divide by 5, the same as 24 divided by 6. So what can we learn from here? That the number of bottles bought is directly proportional to the cost. So this is what we call direct variation, because the answer we get here is 4. You know, in maths, when you get the same number, we call it a constant. And just like I'd written here, constant is a fixed quantity. It is fixed throughout. Then if you check here variable, if I use the word variable, assumes values, which later on I'll be able to tell you that. Now, if I take the number of bottles to be denoted by the variable x, and the cost here to be denoted by variable y, like most of you have gone through the middle school and high school, they know the y-axis and the x-axis. Most times when you plot, you have the x and the y-axis. Now, when you take the value of y, divide by x, we get a constant. And you can clearly see from my table, whenever we divide the cost in dollars, divide by the number of bottles, we get a constant number. So it means when I take y, because I've now let my cost to be denoted by y, divide by x, what am I getting? I'm getting a constant. Are we good? So in mathematics, in this topic of variation, we normally say this y is directly proportional to x. So this symbol means y varies as x. Or in other mathematical terms, as I'd put here, proportional to. Proportional to. So when we come here, y varies as x, or it is proportional to. So mathematically speaking, when you take y over x, you get k, which you have already seen here. So most of the times you say y directly proportional to x, this implies you can write your y to be equal to kx. And this k, we call it the constant of proportionality. Now let me take you briefly back here. What do we do when we do a little arithmetic? When you cross multiply, your y becomes k times x, which we write kx, which is the same as what I've written here. So this is what we normally call direct variation. Because next time somebody will say that the number of students admitted in a specific high school is directly proportional to the amount of school fee they pay. So if we say the number of students denoted by S, then the school fee they pay is F. So we write S directly proportional to F, which means when the students increases, the school fee will definitely increase. You get the concept. Then this one, when you want to write it mathematically, you will write that your S is equal to KF. So this is what we call as direct proportion. And we can always write it in that way. Now, before we go further, we have 4 types of variation. The first one is called direct variation, like what we are doing here. We have what is called inverse. We have what is called the inverse variation. We have what is called partial or partially. Then we have what is called joint. So in this, our lecture today, we will discuss the 4 types of variation. We'll discuss direct, we will discuss the inverse, we will discuss the partial, we will discuss the joint. But please take some notes. So when I've given you a basic, so throughout the direct variation, this is how we can already write it. Are we good? Because somebody can come and say that, you know, A is directly proportional to B, right? So how do we rewrite it? We can rewrite it to be A is equal to KB, because it still produces the constant we had talked about. Allow me rub so that I explain further. Now, I have some question here with me. The question here, they are saying the length L of a wire varies directly as the temperature T. Now they say the length L of a wire, I repeat, the length L of a wire varies directly as the temperature T. So how do we put that? We put it like that. So means this length, it varies directly as the temperature T. Now the length of the wire is 5 centimeters. So they are giving us the length of the wire is 5 centimeters. When the temperature is 65 degrees Celsius. So when the temperature is 65 degrees Celsius. Calculate the length of the wire when the temperature is 69. Calculate the length of the wire when the temperature is 69 degrees Celsius. Now, this is a very direct question. As a Cambridge school teacher that have been teaching international schools for a long time, remember mathematics is the same across the globe, because I still have some students in Germany, I have in the United States, I have them in Canada, in Ohio, I have some in Beijing, in China. So the same concept that is being taught across the globe. Mathematics concepts do not change. Now remember this. You are told that the length L of a wire varies directly. Now this is how we write directly, because it is under the direct variation. So what can we do? We come and say L is equal to KT. Now you all know why I'm putting KT, because I'd already said that it produces a constant. Remember, we had agreed that if you divide by T, in this case, what will you note? That L over T will provide a constant. You remember from our previous table that when you get the ratio, it provides a constant figure. Now, the first thing that we need to do in such a case is to find the value of the constant, because here we have been given the length and we have the temperature. So for you to get the constant here, you take length over temperature. So I take 5 over 65. 5 goes here 1, 5 goes here 13. So it means the value of K is supposed to be 1 over 13. When you know K to be 1 over 13, you can pause my videos to understand it much better. When you know that K is 1 over 13, now we come and say you do not know L. Are we good? But you know mathematically, as I had said earlier, that whenever you want L is KT from this formula. You can even cross multiply it from here. Now I don't know L, but I know T and I know K. So I will come and say 1 over 13, which is K. I multiply by T, which is 69. And remember from your basic numerical values, 13 goes here 1. 13 goes into 69 how many times? Maybe you can use your calculator to solve that. So you simply take 69, divide by 13 to give you the value, of the length. And the answer should be in degrees Celsius. So that was a question from the direct proportion. Now let's move to the next question. A question here comes, you've been given, the question says E directly proportional to M, that means directly proportional. Then you have been asked to find the missing values. Find the missing values. So we have M and we have E. Then here is the table. You have been given 2, 1.2, dash 1.8. Then we have 5 and dash. Now, first of all, how do we find the missing values? Remember, it is a direct variation. Now, once somebody has told you that E directly proportional to M, mathematically speaking, this implies your E should be Km. Are we good? Which still implies our K is the same as E over M. Remember, we divide both sides by M. So you can get the value of K. Now, when you want to get K, you take E over M. Remember our previous table. Are we good? Now, in this case, we can only work with the known values. That if my K is supposed to be E over M, I take E to be 1.2. I take my M to be 2. That provides 0.6. Now I know K. Then they want you now to find M. Remember, our formula still remains the same, that whenever you want to find E, is like Km. Now I know K, so I do not know M. Are we good? So how do we go about it? We say E, in this case here, E is 1.8, is equal to K, but our K is 0.6 times M. And remember, our M was not given, we just write it M. So if you know that 1.8 is equal to 0.6 M, what can you do? We can easily divide both sides by 0.6, divide by 0.6. So our M, can draw here, Our m becomes 1.8 divided by 0.6, which is 18 over 6. Remember, it is 1 decimal each. 6 goes here 1, 6 goes here 3. So this equals to be 3. Now our m in that case becoming 3. The same we can find our e here because we don't know the e here. But remember, our e, if you go back to the formula, it was km. You know, we had to find the equation connecting e and m. Now we know e is km from our previous solutions. So how do we find e here? We take k, but already our k we had worked out to be 0.6 times m. My m at that case is 5. So 6 times 5 is 30. Having 1 decimal place, so we get it to be 3. So in our case here, our e is supposed also to be 3. Do you understand that? So that is basically how we work out the direct variation. Let me show you another one. Now the next question here says that P varies directly as Q. P varies directly as Q. So we come and write P varies directly as Q. If P is equal to 8, when Q is equal to 48. Find equation which connect P and Q. Now if we are told that P varies directly as Q, we know that P directly as Q, this implies our P be equal to KQ, right? So this is the equation connecting the two. Then you have been told P is 8, when Q is 48. So we can divide both sides by 48, So our K becomes 8 goes here once, 8 goes here 6. So the moment you know K to be 1 over 6, if they'd ask you the equation connecting P and Q, you come and write P is supposed to be KQ, but our K is 1 over 6 Q. So this is the law, okay? This is the equation that is connecting P and Q. The moment you know the equation connecting P and Q, you can easily work out any other value that they expect you to get. Okay? Let me give you one more question to try. Given that y varies directly as the square of q, and that x is equal to 2 when y is 3, find y when x is 12. I repeat, given that y varies directly as the square of x, and x is equal to 2 when y is 3, find y when x is 12. Now, here is a question, because I promised that we'll definitely be doing some examples. If I give you time, and I provide here to be speed, okay? Now I give you time, and I provide speed. So if I give 6, I give 4, I provide 3, 2, and 1.5, 20, 30, 40, 60, 80, and maybe we reach 1.0 to be 120. Okay? What do you note? When speed increases, time decreases. And I think that's a very good example in that part. The one that many students know. I know most of you have already known that the speed is always equal to distance divided by time. And you can even as far go as using that model of a triangle, that speed is distance all over time. Time is distance all over speed, then distance is speed times time. Now, this is a very important variation, guys. It is what we call inverse. Can you remember a quantity in life that when one increases, the other one decreases? And I want to make it very clear. Anything that when one increases and the other one decreases, that's what we call inverse. It is inverted. are reciprocal of the other. A good example is here. When you increase speed as a driver, remember you will take a shorter time. Maybe if you are racing towards maybe having a business meeting or some counseling or all that stuff. When somebody drives at 120 assume this one is given in kilometer per hour, and maybe here is given in hours. Whoever drives at 120 kilometers per hour takes only 1 hour. But whoever drives at 20 kilometers per hour will take 6 hours. So if I decide and let the time here to be denoted by t and speed to be denoted by s. Or in many times you like this one to take the x-axis and the y-axis. Right? So it means what happens you do here, when you take x times y, because x is for time, if I get x times y, what do I get? 6 times 20, 120. 4 times 30, 120. 3 times 40, 120. 2 times 60, 120. 1.5 times 80, you still get 120. 120 times 1 is 120. So everything here, when you get the product, you get 120. So here is xy. xy in algebra means x times y. So means if I get the product, I get the same thing. So what do you learn from inverse variation? You learn that xy is equal to a constant. Just like I'd already told you earlier that a constant is a number that does not change. It does not change. So it implies throughout here we always have 120. So it means x times y is equal to k. So any equation of that form is inverted or inverse variation. Now there is something that I would like you to note. For example, if you are to have a graph, somebody were to give you a graph, let me say this, maybe that I provide the time in hours and I give you here the speed. Just plotting this timing and that speed. Remember the time was 1 to 6. So if you start maybe 0, 1, 2, 3, 4, 5, then 6. Then what about our speed? Our speed, we can come maybe here 20, 40, 60, 80, 100 and 120. Remember our main target is, we are just plotting. You are plotting speed and time, which definitely time normally takes the x-axis and speed is taking the y. Can we plot together? When the speed is 20, time is 6. When speed is 20, time is 6. So that is that point. When the speed is 30, time is 4. Speed is 30, time is 4, somewhere there. When the speed is 40, time is 3. Speed is 40, time is 3. When the speed is 60, time is 2. 60, 2. When the speed is 80, time is 1.5. 1.5 is somewhere in between. When the speed is 120, time is 1. Somewhere here. Now our graph, generally speaking, it will be looking like a curve. Okay? So this, anytime you see a graph of that nature, you will definitely know it is an inverted variation, is an inverse variation. So allow me pick another question. Now here is the question, given that the length L of a rectangular varies inversely as its width. Now somebody tells you there is a rectangle, and let me teach you this how to perform well in your mathematics. You should always draw the model. Drawing the model means if they mention a diagram, please draw it. It will picture out and bring something in your mind. First of all, we can draw a rectangle and think how a rectangle looks like. We all know a rectangle has length and it has the width. But here the question says, given that the length L in centimeters of a rectangle, okay, varies inversely as its width. So what do we note? That length times width equal to a constant. What comes to your mind? The physical quantity that many a times used to find area in a rectangle was length times width. So that area being a constant is simply providing under the variation. So A stands for the constant. So we all know that L times W is supposed to be what? Is supposed to be A. So how are we supposed to go about it? We know very well that L times W is K. So we are going to use this formula in all the things we do. And under the inverse variation is like L inversely proportional to the width W. Can you see this formula? That we see our L is inversely proportional to the W. I'm now turning you to the variation way of rewriting it because we had already seen from our previous table that inverse, when we get the two products we get a constant. Now, how can we rewrite this? We can write L equals to maybe a constant over W. So this is how we rewrite our inverse variation. Because we know very well that if we take L times W, we get K, which is still right from here because it's like we have divided both sides by W. When we divide this by W, the L remains alone, which is still the same formula. But under the physical quantity, we learned that when we take length times width, we get area. So this is what we call inverse variation. You need to remember this. But remember the question was asking, given that the length L of a rectangle varies inversely as its width W, if the length is 10 centimeters, they're giving when the length is 10 centimeters, okay, when the width is 4. Now the width is given to be 4 centimeters. Find the length when width is 5. Find the length when width is supposed to be 5 centimeters. Now we need to find the constant of proportionality. The first thing we need to find is K. So how are we supposed to do it? We come here and say L times W provides K. So we go to the one that is provided. We were given L and we were given width. So for me to know K, we take the 10, we multiply by 4. So the answer is supposed to be 40. So the moment you know K, you can find any other value. Remember here they want you to find L when W is 5. But this is our formula from the inverse variation. We know very well that our L becomes the K. But now we know K. We simply divide by W, and W is 5. So when you take 40 divide by 5, you get what? You get 8. So in that case, our L is supposed to be 8. You can pause the video and at least have a look at some of the ways of going through it. Let me take you through another example of the inverse. Okay, the other question here says, find the constant of proportionality in each of the following cases. Now, in this case, we are finding the constant of proportionality. Now, here we have been provided P inversely proportional to V. Then they are saying if P is equal to 40, when V is given to be 12. Now, when we find in this case that our P is inversely proportional, what do we learn from that? I just said under the inverse proportion, We introduce the constant of proportionality. We get our P becoming K over V. Because you know very well for P and V to be inversely proportional, the product of the two must give you a constant. This is what you need to remember. Under the inverse proportion, the product of the two quantities provides what? Provide a constant. So that's what we are supposed to get there. So in this case, we should know that P becomes equal to K over V. So under the inverse, there must be a reciprocal. Something must be at the denominator. Now, can we find our K? Because we know for you to get K, you must get P times V, which is supposed to be 40 times 12. What are we supposed to get? 480. But the question was, find the constant of proportionality. So that is the constant of proportionality in that. And they can as well ask you the law that joins the two. Which law normally joins the two? We can write our P equals to K, which is 480, divided by V. So this is basically the law that joins the P and V. Maybe it is pressure and volume or whatever it is. So that's basically, we have seen how to find the constant of proportionality. Let's try another example. Another example here comes, we have been provided with R is given equal to 1. No, that's not how they've written it. They've written R like that. If R is a half, when R is 2, when small r is 2. Now, how do we find the constant of proportionality in this case? Number one, whenever you see two variables, or simply letters, one is placed over another one. So that what rings to your mind means they are inversely proportional. And the first thing that should come to your mind, the product of the two must give you a constant. So if you take r times r squared, you must get a constant. Or in other ways, you can come and write your area should be equal to a constant of proportionality over r squared. Remember, the two equations are the same, because if I cross multiply here, my k will be r times r squared, which is here. Now we have been given that capital R is half, small r is 2. So how do we get our constant of proportionality? We take the bigger r, which is a half, times the smaller r squared. We take 2 squared, which implies is a half, times the 2 squared is 2 times 2. So this can go with 1, so we get it to be 2. So our k becomes 2. So in this case, the law that joins the two can be written to be r equals to k, which is 2 over r squared. So this is the law that joins the r and the r squared. Are we good? The last part to be learned, there's the last part here, question 3. We have it, they're saying y, this is the question they have written, y inversely proportional to 1 over the cube root of x if x is 8 when y is equal to 3. Now, how do we go about it? The first thing that we must know in that case, if y is given to be 1 over something, what did I say? That's an inverse variation. So what you should learn from that case is that when you get the product of the two, y times, I'm using dot to indicate multiplication. I know some of my students who are in German, they understand when we use dot is times, and when we use comma is like decimal. An example, 6.7, if I were to have, like some of them have in German, you will put 6.7. Okay? Times 3. So this in German interpretation means 6.7 times 3. I know most of them who are online can understand that. But in this case, the dot will stand for multiplication. So we multiply by the cube root of x to get k. Please remember that when you multiply the two quantities, you simply get a constant, right? So that is under the inverse. But now you've been given x is 8 and y is 3. How do we substitute? We take the value of y times. Remember that dot means multiplication. The cube root of x, and our x is supposed to be 8. And we all know how to find the cube root. Cube root means you find a number that if you multiply by itself 3 times, you get that particular number. So it is 3 times the cube root of 8. How do we find cube roots? You write the number, then you factor it out. Like 2 goes here 4, 2 gets here 2, and 2 gets here 1. If you are finding the cube root, you pair them 3, 3. 1, 2, 3. So out of 3, you pick only 1. So I multiply here by 2, and the answer is 6. Which means in that case, our constant of proportionality is 6. So what is the law that joins the two? Y equals k over the cube root of x. But in that case, we will not leave it to be k. We are going to write the number that we just worked out, and our number here is supposed to be 6. So this is the law that joins the y and the x. So guys, you can subscribe to our channel down there. You can like and share to your friends. And keep following. If you need mentorship, if you need counseling, you can always follow through our channel. Thank you guys. We've done the direct, we've done the inverse or the inverted. Now guys, we are turning to the partial. Now let me give you a good example that most of the students in middle school, in high school, in A levels, even in Cambridge, they basically remember that. If somebody provides y equals mx plus c, I know most of you can remember the formula that's the equation of a straight line graph, which is a polynomial of first degree. Now, can we remember what does this one mean? It simply means that y is partly constant and partly varies as x. These are some of the mathematical terms, some of the mathematical interpretations that may give students some difficulty. But remember this, when we talk about a partial variation, means the y equals means is partly constant and partly varies as x. Maybe next time you get t is maybe mp plus n. This is also a partial variation. Whenever we take, it means if t is a variable and p is a variable. When these two are variables, m and n are constants, means numbers. So it means t is partly constant and partly varies as p. Because I know many times in your algebra you will have something like maybe y is 3x plus 10. So y is partly constant and partly varies as x. Are we good? Because we have the two constant. And the word and in variation is a plus. We believe in probability, we take it and as a product. Are we good? Now let me give you a question that will make it be understood. Now the question here is, a variable y is partly constant and partly varies as x. They're telling us that y is partly constant and partly varies as x. Okay? If x is 2, if x is 2, y is 7, and x is equal to 4, when y is 11, find equation connecting y and x. Now that's a very important question that we can try to look through. Now somebody tells you that y is partly constant and partly varies as x. And I've already given an example of a partial variation using the linear equation that you usually have, that y is partly constant and partly varies as x. So remember that. Now they tell you when x is 2, y is 7. When x is 4, y is 11. Find the equation connecting y and x. Now this is how we are supposed to start. We have to form a series of simultaneous equations. So you will come here and write your y is 7, because if you know y is mx plus c, so when y is 7, x is 2, so which means is 2m plus c. When y is 11, x is 4, which means 4m plus c. Find the equation. Now, how do we work it out? You guys, you know what you learned in simultaneous equations. Now, this one we can easily work with you together simultaneously. It's like we have our 2m plus c is 7. Our 4m plus c is supposed to be 11. These are simultaneous equations that we have here. Let me wrap this so we have enough space to do the workings. Now, let's check here. This is a simultaneous equation, and you've learned simultaneous equation. You can solve it by elimination, by substitution, by graphical method, by Cramer's rule, by matrices, and by graphical, and by what we call the Gaussian row reduction methodology. So we have 8 methods that we can use to solve any simultaneous equation. And I want to teach you the easiest. The first thing that you need to do, we can convert this into matrices. Remember, C is like 1C, this is like 1C. So can you help me just extract the numbers? 2, 1, 4, 1. So we have 2, 1, 4, 1. Then we put a bracket. Then we started with M, then C. Write M there, then write C. Equals 7, 11. Remember, when you put them as an array of numbers, this is now what we call the matrix equation. The matrix equation. Now, how do we solve this? I want us to do it in some beautiful way. Now, we've written it in matrix equation, but we can just have these numbers. We can have 2, 1, 4, and 1. Then here 7, 11. Another beautiful way of doing it. You can, first of all, multiply the first row by a number that makes any of the numbers here be the same. So we can multiply here by 2. So if I multiply by 2, I get 4, I get 2, and I get 14. Then the lower part we don't multiply by anything. No, okay, we can multiply by -2. So we have the negative, negative, negative. So the next thing we get here, we don't copy the second row, but we add it to the first. This 4 plus this minus 4 is 0. This -2 plus 1 is -1. -14 plus 11 is -3. Okay? Now when you see this, since here is 0, 0 means there is nothing. When there is nothing, now we have generated what is called a triangle. Can you see this, what we call a triangular matrix? This is now a triangle matrix. Then we substitute back our values. Remember we started with m then c. So this is like minus 4m minus 2c equals negative 14. Then here is the m part is 0, the c part is minus 1. So it is like minus c equals to negative 3. That's the beautiful way of converting it into triangular matrix. The negatives will go, then our c becoming 3. When c is 3, you can come back here and say minus 4m minus 2 times c, but c is 3. So minus 2 times 3 is equal to minus 6 equal to minus 14. Then your minus 4m equals minus 6, you take it the additive inverse. So here we add it, here we get minus 8. Then we divide by minus 4. We divide by minus 4. So our m becomes 8 divided by 4 is 2. So we know the two values. We know our m is 2. And we had already found our c to be 3. That is by using the triangular array. Yes, okay, I'm not teaching you guys matrices. We are doing partial variation. But since we ended up with a simultaneous equation, it made me touch base with the matrices, which I will teach in my next lecture, to comprehensively teach you how to convert a simultaneous equation into triangular matrix, how to find matrix equation, elimination method, substitution, graphical, all the way through. But this is just a method I'm using to solve this. Are we good? Now, once you know m is 2 and c is 3, can we try and prove if it makes sense? If m is 2 and c is 3, if my m is 2 and c is 3, can we test? 2 times 2 is 4. 1 times c is 3. Yes, it is true, it was 7. When m is 2, 2 times 4 is 8. 8 plus 1 times c, 1 times 3 is 3. We get 11. So that method is very beautiful. So these are the values of m and c. But remember the question, what these guys had asked you, y is partly constant and partly varies as x. Find equation connecting x and y. Now we can easily find equation because we know the values m and c. So we'll come and write our y is supposed to be m, which is now twice x, and c is 3. So that is equation connecting the two variables. You can always pause my video so that you can do a bit of the analysis to understand it. Allow me, guys, to rub. Okay, the next question here we have, this is a good question under the partial. The cost of hiring school bus consists of two parts, one of which is fixed and the other one as the distance covered by the bus. Okay, let's hold on that. Let me check on, let's just look into another question. P varies. P is partly constant and partly varies inversely as Q. Now look at that question. Let me write it. P is partly constant and partly varies inversely as Q. If Q is 9, P is 3, and Q is 18, when P is 9. Find P when Q is 12. Now you can see the question by yourself as we work out how it works. Now remember, this is a partial variation. They tell you P is partly constant and partly varies inversely as Q. Okay, there's a line here. When Q is 9, P is 3. And when Q is 18, P is 9. Find P when Q is 12. Now when you see such a question in whatever level, even if it's a little bit advanced in the A level, middle school or high school, it's very direct. Now remember this. Remember always y is equal to mx plus c. When you want to deal with the partial variation, remember y equal to mx plus c, where y and x are variables. The m and c are constants. So you know that y is partly constant, that's c, and partly varies as x. And remember, x must have a constant m. Now let's solve this. Let's look for the solution of this. P is partly constant, so I can say P equals, in fact, let me make it so clear to you, to help you this as your model. Always remember y is equal to mx plus c. Always remember that as your model, like a formula. Like somebody wants to get the area of a triangle, they say area is a half base times height. So this is simply a formula. Now they say P is partly constant, so you write P equals, and partly varies inversely as the Q. So you just put Q, maybe MQ. Just want to put it. Remember Q, these are variables. Remember whatever that is put here are variables. So you put maybe K, Q plus T. Then you have in your mind the P and Q are variables, just like the Y and X. You see, these are simply variables. But K and M constants, P and C are constants. And remember, most of the times you want to score good grades in any math subject, you basically just have to relax and remember the model. By writing the model, then your mind will start thinking on how to go about it. Now we know that P is equal to KQ plus T, which means P is partly constant. This one, partly constant, just like Y is partly constant. And the word and means plus. Partly varies inversely. But remember, the word inversely is what we have not included here. So we have to change our last part. Inversely, so it should be 1 over T. So it should be 1 over C. Whenever you hear the word inversely, the word inverse means a reciprocal. I'm giving you all the best ways to remember. Remember, if it is just C, that means direct. But if they say and inversely, which means 1 over that. Okay? Now, when Q is 9, P is 3. Now, P is 3 when Q is 9. So that is 9K plus 1 over T, which I don't know the T. Then Q is 18 when P is 9. So P is 9, Q is 18, so it's like 18K plus 1 over T. So this is what we have here. So it is also forming another simultaneous equation. You have it 9K plus 1 over T equals 3. Then 18K plus 1 over T equals 9. Today, guys, I'm not going to teach you about how to solve a simultaneous equation. I will use any model to work it out. But my next lecture, I'll take you about that. So what we can do here, we can do a subtractive inverse. We can eliminate the idea of T. We can say 18K minus 9K is 9K. 1T minus 1T cancels out. 9 minus 3 is 6. then divide by 9, divide by 9. So this implies your k is 6 over 9, which means 3 goes here 2, 3 goes here 3. So your k becomes 2 over 3. Okay? Then you can get back to find the value of what? The value of k, the value of t. So 9k means 9 times 2 over 3. What is 9 times 2 over 3? 9 times 2 over 3 plus 1 over t equals 3. Now this we can put over 1. The 3 goes here 3. 3 times 2 is 6. So 6 plus 1 over t is 3. Let me write it here. 6 plus 1 over t is 3. We can have our 1 over t becomes 3. Then we minus 6. So 1 over t becomes negative 3. If 1 over t is negative 3, which means t is negative 1 over 3. Remember, we take the reciprocal both sides. If 1 over t is negative 3, which means t should be 1 over negative 3. So we know the value of t, and we know the value of what? The value of k. But they wanted you to come up with the equation connecting p and q as variables. So the equation connecting the two was here. It was supposed to be p, right, equals to k. But remember now, my k is supposed to be 2 over 3. So we write 2 over 3q plus 1 over t. But remember, our t is 1 over negative 3. So if, okay, 1 over t was even here to be negative 3. So plus minus 3, which becomes minus 3. So this is the equation connecting p and q. So it means p is partly constant and partly varies as q, where the 2 over 3 and negative 3 are supposed to be what? Are supposed to be constant. You understand that? How the partial variation normally work. Before, now we've learned direct, inverse, and partial. Now let's do the last part, which is the joint. Now let me give you a common formula that all of you knows. Whenever you want to find interest, is principal times rate times time divided by 100. I think this is a familiar formula that if I put here, most of you can remember. Now the interest, this interest varies directly as the quantities p, q, and r, and t I mean. Interest, which is I, it varies directly as the three quantities. And remember, if we can rewrite it, our interest I should be like 1 over 100 times p RT. So our 1 over 100 will be the constant of proportionality. It will simply be a constant of proportionality. In what way? Because our I is like directly proportional to P RT. So when we come here and say our I equals to K times P RT, remember these are variables. This is the constant of proportionality. Do you remember when we started with our direct variation that the two products was giving you a constant number? When we talked about the amount of money paid in euros or dollars and the number of liters of milk, when the milk increases, the cost was becoming high. So when we multiplied the two, we get a constant. So the same as here. When you multiply some two stuff here, you simply get a constant. So this is what we call the constant of proportionality. Now, this is now what we call joint. This is now what we call joint. Now, let me give you an example. Volume V of a cylinder. How do we find the volume of a cylinder? We all know that the volume of a cylinder is pi r squared height. You take the pi, which is a constant, you multiply by radius squared times height. Remember, radius, height, and V are variables. They keep changing. The only part that does not change is the constant, which is pi in many cases. let me look for a problem here to solve now that I've given you the basic of what we call the joint variation. Now listen to this. A quantity y varies directly. A quantity y varies directly as a quantity x, and inversely as cube root. Inverse means over the cube root of z, and inversely as the cube. They talk about not cube root, the cube. Cube means z power 3. If x is 12, if x is given to be 12, z is 2, and y is 1 over 24. Find the equation connecting the three quantities. Now, how do we find the equation connecting? They may ask you to find the law connecting the quantities, the equation, the formula, all those terms. But remember this, the first important thing that you need to find is basically the constant of proportionality. Because they had already said y is directly proportional as z, and means, for example, if we would have rewritten it to be y this way, x dot z cube, it means y is jointly, these are joint variation, because it is directly proportional to both z and z cube. But remember, it is now inverse for z cube. But when we bring the idea of the inverse, we put it over reciprocal. Are we good? That's how we deal with the joint. You see the two quantities. Now we can come and say our y equals maybe k x over z cube. Remember, most of the times we take, okay, let me rewrite it this way. Y equal to k times, in bracket, x over z cube. This is a joint variation for both x and z cube. And the reason I'm putting the z cube below means it is inversely proportional. So this and an inverse, the top is direct, but the two of them are joint. Just like I'd already shown you there, the simple interest I should be P RT over 100, which we can have to be I to be 1 over 100 times P RT, like that. So the constant of proportionality multiplies something. Are we good, guys? It simply multiplies something. Now, we want to substitute and know the constant of proportionality. What am I supposed to do? X is 12, Z is 2, and when Y is 1 over 24. So here, Y is 1 over 24 should be K, which I don't know, times X. And X is 12 over Z, but here is Z cubed. So 2 cubed is 8. Which means 1 over 24 becomes 12 divided by 8 is the same as 6 divided by 4, which is the same as 3 divided by 2, which is 1.5. So we get here 1.5 times K, which is 1.5 K. Now, if we know that 1 over 24 equals 1.5 K, or we can rewrite it in a simpler way, 1.5 the same as 3 over 2 times K. But remember, when you get any coefficient times a variable, we reciprocal. We get the reciprocal of that coefficient. So we multiply times 2 over 3 times 2 over 3. Then the 2 will go, the 3 will go. So our K becomes 2 gets here 1, 2 gets here 12. So we get 1 over 36. So remember, the constant of proportionality here is 1 over 36. Then they wanted us to get the equation joining the three variables. So how do we go about it? We simply substitute back in the formula. We knew very well that our y was supposed to be k x over z cube. So we come and write our y is supposed to be k, but my k now is 1 over 36 times x over z cubed. So this is the equation joining the 3, which we can still rewrite. This implies your y can become x over 36 z cubed. So this is the law, and that is simply like the general formula that connecting the 3 variables. Let's rub and get to the next part. Here is another question, guys. We have been told that the mass of a certain wire varies jointly as its length and the square of its diameter. The mass of a certain wire, call it M. The mass of a certain wire varies jointly. So we can put the variation symbol, varies joint as its length, and the square of its diameter. And the square of its diameter. If 750 meters of wire, so means when the length is 750, if 750 meters of wire of diameter 2.5, which means when D is 2.5, has a mass of 45 kilograms. Mass is given to be 45 kilograms. What will be the mass of 1.5 kilometers of wire? Which means if the length is 1.5 kilometer, remember these were meters. What will be the mass of 1.5 kilometers of wire of diameter 4.5 millimeters? So diameter 4.5 millimeters. Remember the first one was also millimeters. Now this is a very important question to note, that I'm repeating the question. The mass of a certain wire varies. So the mass I take to be M, it varies jointly as its length and the square of its diameter. Jointly means the product of the two, just like we talked about pi r squared and all that. Now we've been given the length, the diameter, and the mass. Now here they are not providing the mass here. Now, when we know that these are joint variation, then we have to introduce what we call the constant of proportionality. So you come and say M equals maybe K times LD squared. Having in mind that our K is the constant of proportionality. So can we find it over here? We can come and say when the mass was 45 times K, our length was given to be 750 meters times diameter, which is supposed to be 2.5 millimeters. Remember, you need also to know how to work with those conversions. So your 45 kilometer becomes K times 750. Remember, when you convert millimeters into meters, you have to divide by 1,000. So times 2.5 over 1,000. That 0 will cancel out. So we are going to get our 45 should be K times. So we have to multiply the 275 times 25. We multiply the 2. We get 25 2, 3701, 15, 57, 1875. But remember, we had the decimal here plus another 2, so there are 3. So it should be 1.875. So whenever you want K, you divide by 1.875, 1.875. So that implies our constant of proportionality becomes 45 divided by 1.875. So when we divide the two, we definitely get our K. Now the question is, they wanted you to find M, while D was 4.5 and L was 1.5 kilometers. And remember, you need to change kilometers into meters. You have to multiply by 1,000. So we come and say our M becomes K, because I now know K to be 45 over 1.875 times L. Remember, my L is given to be in kilometer. So we have to multiply by 1,000, knowing very well that 1,000 meters is equal to 1 kilometer. So 1.5 times 1,000, we get 1,500. Then we multiply by the D squared. The diameter is 4.5 millimeter. And since we were both using millimeters, we do not change. So we multiply by 4.5, then we square that. So when you get the working from that, which you can definitely key in into your calculator, you will basically get the correct answer. So guys, you can subscribe to our channel because we do mentorship as well. You can get in touch with us. You guys, you can reach us by calling, basically for mentoring, which we mentor the high school student. We also normally have the online conferences. We also do the one-to-one meeting in the nearby place and discussing some of the basics of what a high school student should do, how a high school student should study, the key areas they need to spend time. We have understood the curriculum, the Cambridge curriculum. We know how it connects. The topics that somebody not doing well in year 11, even in year 11, they need to go back to the year 6, the year 5. And we bridge the gap of divide between the two. So that's how we help so many high school students. We mentor them, we provided with a lot of revision materials, the past papers, how to work them out. And mostly in our video tutorials, they revisit after subscribing and knowing how best they can do well. And this is applicable to Kenyan system, which is the local. We do to the Cambridge, the American students. We do to the International Baccalaureate, that is the IB. We do to the EdExcel, GCE. And not only here in Kenya, we do across from Germany to Canada, to the United States, to China, across all the 7 continents. So we are trying to find better ways on how to help the young people do well in their studies. So we've basically done a lot of models. We are a team of experts. Like me personally, as Teacher Boaz, I'm a professional in mathematics, from middle school to high school to A levels, all the way to the university. I've taught Cambridge system for over 10 years now, with lots of wealth of experience. And most of the students I mentor and guide, they do well in their A levels, get A stars, joining the league universities, and they get better courses. Thank you guys, and make sure you subscribe.